Hello, I'm Kumar Abhishek, and this video is made as part of assignment for deep learning. So, this assignment is about Retina Guard Diagnostic, which is a med tech startup, and the task is to develop an AI tool to screen for diabetic retinopathy for retinal fundus image. The goal is to classify the severity of DR on 0 to 4 scale to help prioritize high risk patients in remote clinics. Dataset used is APTOS 2019 blindness detection, which is on Kaggle, and the link is shown. So for this, um, I have written the code which is shown in the right side, which is on Kaggle itself, because the dataset was on Kaggle. I decided to put code there, um, and I have used Keras, um, and which is under like TensorFlow, and then NumPy, Pandas, and sklearn libraries are used. So here you see the dataset is like the files are read from the input, and then I'm reading the images, and the dataset is built after that. VGG and RES datasets are built, and then um, I'm going to train the models. So AlexNet here, the resolution is 2 to 4 into 2 to 4. That's defined up as well. Activation in the mid is used is ReLU, and in the end I've used softmax. So during the output, so you see that here, and the same for VGG and same for ResNet 50. So all three coming one by one, and in the end I have evaluated them together so that they can give the output. So when you see the first one, the epoches are running, and it is for uh, VGG 16. The uh, loss is reducing and the accuracy is increasing as we go further, and same is for the next one, which is RESNet 50. The results are here, and for um, LXNet, the results are here. So these are baselines that I have shown in the left side in the table, um, and you see the accuracy, F1 score, recall, and precision that came as output for each of these. So when we see here for the first one, which is BSG 16, acceptable overall occupancy, but modest macro recall F1, right, and indicating missed minority classes. AlexNet, when we see that, it has slightly better macro F1 recall than a VGG 16, but yet still limited for severe class in an imbalanced dataset. ResNet 50, when we see the results, it's clear underfitting when only this head is trained, exacerbated by class imbalance and sensitivity to preprocessing choices. So next was again to improve the ResNet 50 that I decided, right, because the bias and variance diagnosis and all those diagnoses, uh, decided to go with ResNet 50, selected for fine tuning, right, and then um, decided to go further with it, fine tuning and augmentation, class weighting, and optional focus loss. So this is all, this code is uploaded as well, and then if you see, I got a better output, the loss were reducing, and then finally I got the output that is shown in the output section here, right. So it is much better. The fine tuning is done, and then the class weighted class entropy and focal loss combined with the target oversampling for class 3 to 4 to counter APTOS, right. So used to implement a fine tune, and the class aware loss to explicitly raise sensitivity for minority severe classes, right. So it is a good result, and the output is as expected, so fine tuned, and the gain over the frozen baseline indicates reduced false negative across classes and better precision recall, balance, appropriate for trigger and high risk patients in remote clinics. Thank you.